Okay, so today, what's next in trigonometry is basically proving trigonometric equations and then proving trigonometric identities, right? So since you're taking this A2 class, right? This A2, I wouldn't even call it a class, but since you're watching this A2 video, I'm going to assume you've already done AS. So you should already know how to prove trigonometric identities and, prove that the left-hand side is equal to the right-hand side and so on. And also, I don't think I can make a video like explaining how to do it because it really varies by case. Like it keeps changing. There's not an exact formula. This is not this is just a question type, not a formula, a demanding thing. You just to do these types of questions, you should really know your trigonometric formulas. If you can memorize them, you should have your data booklet by hand because it'll help a lot. So the question is asking by first expanding cos square x plus sine square x cube, show that cos 6x plus sine 6x is equal to 1 minus 3 by 4 sine squared 2x. Okay, so this is a very daunting question. It's quite tricky. When I first looked at it and I tried solving it, I actually found it quite hard. And you would be surprised to know this is only worth 4 marks. Yeah, this entire this almost impossible question is worth 4 marks. So let's first do the first part of the question, which is first expanding cos square x plus sine square x. So don't be confused by this. Although it does say cos square plus sine square. So we know from AS and A2 that cos square x plus sine square x is equal to 1. But it's asking expanded beforehand. So don't replace it with 1 just now. Okay, so we know that, actually I'll keep that written over here because it'll help, right? It'll help over here. So this is equal to 1. Now, if it's cos square x plus sine square x cube, I have to cube the other side of the equation as well. Covered this in the last video. To do something to the left side of the equation, you have to do the same to the right hand side. So if I cube both, I can see that cos square x plus sine. This was the hardest part of the question, figuring this out, is equal to 1. Okay, so this is what we should equate this to. Now let's start expanding. Because we know that 1 to the power of literally anything is, going to be 1. Okay, let's move on. Cos square x. Okay, so there's A2 binomial theorem and there is AS binomial theorem. Here the power is a positive whole number, so we won't have to use the A2 binomial theorem, the really complex one, n into n minus 1 over factorial. You don't have to do any of that. Here you can just apply the AS, like the easy thing we learned in AS, and C, remember that. So I'm going to assume you already know that. If you don't, you can watch my videos on binomial theorem that I covered. But you should know this. If you're in A2, you should know this. So 3, what is with this pencil? 3c0 cos square x, 3 sine square. There's no need to write sine square because we're going to power it to 0 anyways. Plus 3c1 cos square x squared sine square x. Oh, I'm running out of space. Okay. Actually, okay, you guys know that anything to the power of 0 is going to be equal to 1, right? Sine square x to the power of 0 is equal to 1. You should know that anything to the power of 0 should be equivalent to 1. Not should, it is equivalent to 1. So save space, I'm just going to be moving on. 3c1 cos square x squared sine square x plus 3c2 cos square x sine square x squared plus, I want to move it over here. Okay, cos square x 0 sine square x cube. All this is equal to 1. Okay, let's now first start multiplying. Get your calculators out. Mine is in my bag. 1 second, I'll be back. Did not come prepared for this video. Okay, so 3C0, we know beforehand that it's always going to be equal to 1. So 1 into cos square x cubed is cos 6x. Let's move on. Okay, 3C1 is equal to 1. Sorry, it's equal to 3. So 3 cos 4x, because it was cos square x to the power, well, look over here. It was cos square x to the power of 2. So 2 would multiply here, and you would have cos to the power of 4. And sine square x, it has power 1, so no changing. And 3C2 should also be equal to 3. Yeah. Weird plus symbol arrow, so plus sine 4x plus, okay, 3C0 is also equal to, 3C3 is equal to 1. So I'll write it just in case. Cos square x is equal to 1 as well. So there's no need to write cos square x. Sorry, you can just straight away write sine 6x because I expanded this. Multiplied this with this. Equals to 1. Okay, now let's start. Let's get rid of those brackets and, shorten our equation down. So cos 6x plus 3 cos 4x sine square x plus 3 cos square x sine 4x plus sine 6x is equal to 1. Okay, I think I'm going to have to use another page because I want to keep my working over here. Okay, how did I solve this? Yeah, okay. Let's look at our question over here. You can see that they moved basically everything except for cos 6 and sine to the power 6 to the right hand side of the equation. So let's keep this where it belongs, basically the left hand side of the equation, and let's move everything else to the right hand side. Actually, I would like moving 1 to the left hand side as well. You'll see later. So cos 6x plus sine 6x. Okay, I want to move 1 to the left hand side. You'll see. And let's move this over here, and let's move this over here as well. So that would be negative 3 cos to the power 4 sine square x. Negative 3 cos square x sine to the power 4x. Acha. What is the question exactly asking over here? Okay, we need to take 3 as our common factor. Let's factorize this. I'm going to go to the next page and rewrite what we did over here. Cos 6x plus sine 6x minus 1 right? I just don't want to copy it down incorrectly. Okay, now let's take factors. Let's take what's common. Cos 6x. I want to keep this side of the equation unchanged. I want to change the right hand side. So you can see that negative 3 is common for both. I'll switch to highlight. So you can see negative 3 is common for both these terms. And you can see cos square. Oh man. Yeah, you can see cos square and sine square is common. So let me show why that is. So let's move 3 cos 4. Let's isolate this term for a second. Cos squares, okay, and let's do cos square sine 4x, right? So why is cos square x and sine square x both common common for both of these terms. So you can see we can break this down into 3 cos square x, cos square x, sine square x. I just don't want you guys to be left behind, like not understanding what I've done here. And you can see, okay, sine to the power 4 is basically sine squared squared. And when you square something, you're multiplying with itself again. So you can see that, what can you see that's common in these two terms? You can see not only is minus 3 common, but you can also see that cos square x and sine square x is common between these two terms. So let's just erase this and go back to the top. Okay, so we found out that minus 3 was a common, cos square x was a common, and sine square x was a common. Okay. So into that would leave cos. Actually, yeah, I should have kept that. I should have kept that example down to show you guys. Right. So I'm gonna write over here minus 3 cos. This is a very tricky question, so I'm gonna go really slow here just to show you guys. Okay, so we took these highlighted terms out, right? So when we took minus 3, we took this. Just follow where my highlighter is or where my laser is pointing right now. Okay, so okay, so we took minus 3 common, we took cos square common, and we took sine square common. So just get rid of all 3 of these highlighted values, and what are you left with? You're left with this. Let's look over here. So we took minus 3 common, we took cos square common, and we took sine square common. You're only left with this. So we can move it over here, right? Cos square x. Okay, so we took negative 3 as common. So when you take negative 3 as common, you'll have to change this to positive sine square x. I hope you guys understand what I did here. Because when you multiply minus 3, I'll shift to a highlighter mode. So when you multiply minus 3 with sine square x over here, it would become minus 3 cos square. Minus 3 cos square sine to the power 4x. So since I took negative 3 as a common and not positive 3, in the bracket I'll be left with cos square x plus sine square x. You know, sign changing. So you guys already know what this is equivalent to. I don't even have to tell you this is equal to 1. You know this. So we can move back, and I think I can get rid of this over here now that we're done factorizing. Okay, so let's continue. Cos 6x plus sine 6x minus 1 minus 3 cos square x sine square x. Okay, so we're left with this. Because we know cos square x, like this is equal to 1, so we don't even have to write 1. We know anything multiplied to 1 is itself. Okay, now let's open our data book list together. I want you to Google MF19, and I want you to open that and go to trigonometry and look through those formulas, and I want you to find what sine 2x is equivalent to. If you haven't already memorized it, just go to MF19 and look through trigonometric ratios, or just the trigonometry side. Find what sine 2x is equal to. I'll open it with you, but I know from memory it is 2 sine cos. So I'll just double check because I don't want to get it wrong in front of you. So let's look. Yeah, 2 sine cos, yeah. So MF19 says that sine 2x is equal to 2 sine cos. And look at this equation over here. It's not sine square x, it's sine square 2x. And I told in the previous video that sine 2x into sine 2x is the same as writing sine square 2x. So how can we convert whatever we have over here into sine squared 2x. I'll show you guys right now. Let me just remove this. Unfortunately, I have to rewrite this because that's just how maths in A-levels is. You have to like rewrite this over and over and over again. So minus 3. Okay, so cos square x, sine square x. If I do, actually, how do I explain this to you guys? Let me think. Okay. So we can rewrite this as cos x, sine x. Actually, that would be cos x, sine x, cos x, sine x. That is going to be equal to cos square x and a sine square x because cos, multiplies with this and this multiplies with this. Okay, now that we have that written. Now, remember MF19, it said sine 2x is equal to 2 sine x cos x, right? But over here, we're missing 2. Okay, so what we do here is we kind of manipulate this value. So we would do minus 3. We introduce a 2 over here, cos x, sine x. Just 1 second. Suspend your disbelief for 1 second. And let me show you. Cos x, sine x. Okay. So why was I able to add these 2's over here without any repercussions? I do face repercussions here. I'd have to divide this by 2. And then I'd have to divide it by 2 again. So it would be minus 3 divided by 2. Or minus 3 divided by 2. Divided by 2 again. Right, because not only did I place 2 one time over here, I placed 2 again over here. So you can manually put this in your calculators, but you should know that minus 3 over 2, when you divide something, you take the reciprocal, so that would be equal to minus 3 over 4. So we can write minus 3 into 2. And let me just get rid of this over here. I'll rewrite that again minus 3 by 4. Okay, so this is equal to, as I wrote beforehand, let me just undo and show you guys again. Sine 2x is equal to 2 sine x cos x. You should memorize this. Let's move on forward. So minus 3. So I'll replace this and I'll replace this with sine 2x. Sine 2x, sine 2x, which will be equivalent to, let me just get rid of this, minus 3 by 4 sine squared 2x. And you have to rewrite this over and over again. So I'll rewrite it over here. Cos 6x plus sine 6x minus 1. We're not done yet. You can see over here the final equation is 1 minus 3 by 4 sine squared 2x. So all we need to do is just move on over there. Am I using ballpoint? Yeah. Okay. So our final equation after all this work would be sine 6x. So minus 1, we move it back over there, would be plus 1. The sign changed. 3 by 4 sine squared 2x. Now that was your entire question. And that was only for 4 marks. Literally, that was only for 4 marks. A2 math is hard, so if you don't keep up, you will get lost behind. So just work hard every day. That's all I can say. Because when I saw this was worth 4 marks, I was questioning taking mathematics in A-levels. Like, oof. Alright, I hope you guys understood what I did here. And I'll do another example video after this for another trigonometric identity. But I think this video is already long enough.